Still working on the practice problems associated with sample problem 4-2. We're working on number 2, start with A. Write the noble gas notation for 10 represented Sn. And then how many unpaired electrons are there in an atom of 10? Now, we're not being asked to write the complete electron configuration notation for 10, so I'm not going to do that. I'm just going to stick with the noble gas notation. Noble gas notation is incredibly useful because it saves a whole lot of time. So if you need to go over the complete electron configuration notation for a particular element, please watch one of the videos on the earlier in this playlist, particularly practice problem number 1. And we'll go. I went over that already. But here I'm going to save some time, and I'm going to find 10. It is number 50, and I'm asked to write the noble gas notation. So I need to find, moving backwards, the nearest noble gas. That turns out to be krypton, number 36. Okay, so that's going to allow me to represent all 36 of those electrons just by writing Kr in brackets. And now I don't have to write all the way from the beginning 1s2, 2s2, 2p6, yada, yada, yada. One of the things you want to watch out for is, even though I've represented, this is 1, 2, 3, 4p, right? This would be 4p6, krypton 4p6. 4p6. I'm not representing the 4d electrons, these 4d10. Okay, I'm not representing those. Okay, when I say Kr, obviously because these electrons fill after Kr. The only reason I'm bringing it up is because this is 4p. 4d is part of the same main energy level, but it fills after 5s. So we do need to make sure that we include those. Even though it fills after 5s, we have to write it in our configurations first, and then we can go to 5s2. And then how many electrons in p sublevel do we have for 10? So that's 5p1, 5p2. So 5p2. And that's it. That's the entire noble gas notation for 10. I successfully represented a 50, right? 50 electrons just by writing that. It saves me a whole lot of time. Last question. How many unpaired electrons are there in an atom of 10? And so in order to answer that question, I'm going to investigate this highest energy sublevel, the 5p sublevel, and to see what it looks like. So I'm going to represent my 5p. These sublevels have 3 orbitals. And how many electrons are going in those orbitals? 2. I'm going to go up and up so that I can satisfy Hund's rule. And I can see that I have 2 unpaired electrons. So 2, that's unpaired. Sorry for that writing gaffe. 2 unpaired electrons. B, how many electron-containing d orbitals, so specifically d orbitals, are there in an atom 10? Name the element of the fourth period, or in the fourth period, whose atoms have the same number of highest energy level electrons as 10. Okay, so how many electron-containing d orbitals are there in 10? So when I look at 10, in order to get to 10, T-I-N, right, not the number 10, I have to go through 2 different D sublevels. 2 different D sublevels. So 3D and 4D. So I have 3D and I have 4D. Okay. Now, looking at the periodic table, I can tell that both of them have to be completely filled up. All right, I have to have a full 3D sublevel and a full 4D sublevel before I can actually get to 10. So that means every orbital in each of these sublevels is going to be full. So how many orbitals are there in a D sublevel? 5 orbitals. How many d orbitals are we talking about here? We're talking about 2 different sublevels. So that is a total of 10 d orbitals that contain electrons. Okay, they all contain electrons. If it was some other element, especially one of the elements in the block, that number could change, right? We might only have 1 d orbital containing an electron, right? Okay, but 10 is in the p block, and so all of those d sublevels are going to have to be completely full. All right, next part of the question. Name the element in the 4th period whose atoms have the same number of highest energy level electrons. So, highest energy electrons. Highest energy electrons. Okay, so 1, 2, 3, 4, 5. 10 is in the 4th, or sorry, 10 is in the 5th main energy level. I just counted to 5, I promise. But in the 4th main energy level, okay, 4th main energy level meaning this one right here, which element has the same high energy electrons? And so what that means is I just go up, right? Because this is going to be the highest energy electrons are going to be P2, right? Just like 10, P2. It just so happens germanium is 4P2, while tin is 5P2. They're both P2. The question is asking what element has their highest energy electron at P2, but in the 4th period. So, which element has the highest energy electron of 4P2? It's germanium. Okay, so Ge or germanium. Okay, now when you go to answer these questions, make darn sure you have a periodic table out, or it's going to give you quite the headache. Quite the headache.